Okay, good morning everyone, and welcome to this session about alarm analytics in Broadcom's DX APM 11 AR's platform. My name is Janne Koponen, and I work as a customer success advisor at Broadcom. So today's agenda is about alarm analytics and those 5 sections of it. So we look at the alarm views, how to navigate them, how to find the stuff you're looking for. We'll also go through the different alarm types, and we'll dwell briefly into the ways these alarms are either generated or analyzed and grouped, namely the algorithms behind it. And we also look into what to do with the alarms once the time comes, and that is what we refer to with alarm remediation. And finally, and the emphasis really is on the last part, we are going to go into a live system and look at how to deal with alarms in one of our demo systems. So that's the demo part. Today we won't have any questions because this is a recorded session, but if you have any questions, please contact your Broadcom representative. Okay, so once you get into the solution, and I really have these slides, by the way, here as a kind of reference. So we'll go through this in the live system anyway, but I have some written bits here on top of screenshots, so that if you have any questions and you wonder what exactly did that mean, you can always scroll back to the slides and have a look. So hence these little speech bubbles there to to explain what these things mean. So most of those screens here that you will see will contain a filtering section, and that's quite typical of these solutions. So nothing new. But here we also group things into a kind of summary so that you have all your alarms indicated as by the device. For instance, the top 5 worst performing devices will be listed there. You have also the top 5 variants listed alarms there, meaning that the more variance there is in terms of metric values and alarm numbers, those will be indicated. You can also see the alarms grouped there by the severity of it, so critical, etc. And this is all pretty much clickable. So once we go through to the demo, I'll show you where to click to reduce the noise. And this is first step in the solution towards noise reduction and reducing alarm fatigue. So filtering is typical. We have several other things, and I'll talk about this during the slides and during the demo. One more thing about this screen is the top right corner. So, of course, besides just reducing noise, there's things you can do with the alarms. Well, one of the typical ones, for instance, is to go and acknowledge the alarm, assign it to someone who should deal with it, or open tickets in a service desk type solution. We have a direct integration with service desk, by the way. Or in terms of remediation, I'll also show you a slide a little bit later about how to automatically deal with the alarm. So, all of this is in one screen. So you can filter, you can deal with the alarm, you can see details of it. But like I said, we'll go into the detail of that. So I'll go forward with the slides for now. Brief list about the different alarms types in DX APM 11. So when you look at this list, it looks fairly typical. So you have your anomaly alarms, you have your service alarms, rule alarms, situation alarms, and prediction alarms. And I'm pretty sure that you'll all recognize at least 3 of them. So anomalies, prediction, and raw alarms, pretty self-explanatory in the sense that anomalies are the odd ones out. They are the variations from the trend. For anomalies, obviously, like everybody else, we look at past trends of the metrics that we are monitoring. So we are looking for outliners, but also to produce the anomalies, we use quite clever algorithms, in this case, kernel density estimation, or KDE as it's called. That's basically looking for variation over time in the metrics. But at the same time, we are also applying a thing called Western electric rules to actually determine what is normal. So we don't just set a static threshold for these anomalies, and every time a metric value goes over it, we raise an alarm. We look at the trends over time to determine what is actually normal. And an anomaly is finally raised as an alert once the odd value out is in the very rare band for long enough. Right? So there's a little bit more machine learning and intelligence behind those anomalies than the typical solutions in the market. The other one that you might think, what is that, is the service alarms. And service alarms are another way of reducing noise or grouping alarms. So these are related to a service, and we'll go briefly through what a service is once I get to the live demo as well. But just to mention for now that a service can be configured in APM 11, and that is typically a set of devices and set of applications running on those devices that serve your critical business application. So you can group your devices so that you have an actual image of what serves your, say, banking web application. And all the alarms then related to those devices and applications are grouped together into service alarms. And that's a very, very good way of finding problems in a particular area of your devices, i.e. in that business, very quickly. So the situation alarms is the one that probably also catches the eye there. Situation alarms are groupings of raw alerts that our algorithms have detected to describe the same incident, issue, or what we call a situation. So we look at the different alarms coming in from topological, time, and textual point of view. We normalize the texts coming in from different devices and the timestamps and the alert names. We look at them and we determine whether they actually describe the same situation. For instance, you have a device running out of disk space that causes other alerts in different parts of the topology of the business service or the alerting system. But normally, when people go through these alerts, they would not make that link that easily. They would have to go through the raw alarms to determine, okay, this is related to that, and that is related to that. What we do is, with the algorithms, is to actually detect these things, the things that are related to each other, and we group them into situations, and we therefore reduce noise considerably. And I'll touch that again when we get to the actual live demo, and in the system I'll explain a little bit more about these use cases. One slide about alarm severity. So this is pretty standard stuff as well. So critical is red, major orange, minor yellow, informational light blue, warning teal, and green any other. And you might also see some gray alerts. And these are typically alerts coming in from the APM monitoring, so back-end monitoring or front-end monitoring, because obviously our APM solution runs on the same platform as the AIOps solution, so they are tightly integrated and bidirectional. So if something is already closed in APM, but is still visible in the AIOps alarm analytics, it will be indicated as being gray. So it is resolved, but we still preserve it there as evidence of what has happened. Okay, let's briefly go through the different alarm types in a little bit more detail. So the raw alarms, I mean, that's exactly what it says on the tin. So these are raw alerts coming in from different monitoring points. So for instance, application performance monitoring, you might have your NetOps monitoring devices in place. You might be monitoring a disk with our UIM solution, et cetera, et cetera. But there is also the wording any other. And this means that AIOps allows you to plug in any other alarm producing point tool as long as it supports a REST interface. So if we can connect to it using the inbuilt REST interface and pull alarms out of it, we can then collect alarms from different sources into this one big data repository, our AIOps solution, to be analyzed. So this is the power behind one of the big points about our solution is that we allow third-party data to come in. Service alarms, like I mentioned, they are related to a business service and the devices and entities and applications underlying that business service. So using that, what we call topology of these devices and applications, we group the alarms incoming from the monitoring tools, monitoring the different devices and applications in that business service. But we don't just do that. We don't just group. We also use algorithms to determine where is a root cause for a group of alerts affecting this business service. So like I mentioned before, say for instance, you run out of disk space somewhere, that creates an alert. Then that propagates into a different part in that topology of that business service and creates different alerts in different parts, like in the application side of things, for instance. Of course, that will be affected by disk space running out. But what we have underneath in the AI platform is a thing called RCA, or Root Cause Analytics Engine. And that will, when it detects that there are different types of alerts coming in from different devices, but they again might be caused by one underlying single alert, the engine underneath will look at these different alerts in the service and try to determine where the root cause for the whole thing is. Obviously, what that means is that when you fix the root cause, all the rest of the alerts will disappear. So this is one way of figuring out where the actual problem is, and it also helps, again, to reduce noise. A little bit similar are the situation alarms. So this is to do with noise reduction as well. So imagine you have your first level operators trying to analyze a huge list of incoming alerts from perhaps several dozens point monitoring tools. So these alerts are coming in unstructured. You may even have different teams looking at the different alerts coming in from NetOps, coming in from wherever. And the problem with that is that, of course, these guys at level one, they won't be able to even talk to each other. So the thing is, to reduce the noise, we group these alarms algorithmically into relevant groupings. These we call situations. These are the incidents. So we use the algorithms to analyze, again, the text of the alerts, the timestamp of the alerts, and also we look at where in the underlying topology of devices and application that alert happens to be. So using this mechanism, and I'll show you later, as you can see on the screen, we, in this case, achieved 94% noise reduction in terms of incoming alerts. So instead of dealing with thousands of alerts, the first level operator might only deal with a few dozen alerts. Okay, I touched on the anomaly alarms already. So the difference between anomaly alarms and the other alarms is that we look at the underlying metrics and trending of the metrics from the past. So hence, at the moment, we can really only generate anomaly alarms from point devices or monitoring devices that can actually pull the metrics in. So if we just pull the alerts from the third-party monitoring tool, that really doesn't produce anomalies because we have to look at the metrics as well. Okay, so how does it work with anomaly alarms? So we look obviously at the metrics, and if a deviation is detected, like I said, an algorithm called kernel density estimation kicks in and looks at each metric, trying to determine what is normal. And the normal ones are the green bands that you see in the graphic there. These are what we call common bands. So if a value then, according to Western Electric rules, stays outside these common bands long enough, it will be flagged as anomaly. And that will then obviously cause an anomaly alert to be raised in the solution. Last thing on the list, prediction alarms. And this is also quite typical for the industry, that, you know, we try to predict what's going on based on historical trends. So what is going to happen in the future? For instance, we can see a trend that disk space is filling up, or CPU usage going up, or heap usage is going up. We can then predict based on the data when and what time in the future we will actually run out. So then we can remediate this situation before it actually occurs. So I did mention the root cause there in relation to service alarms. So just a little bit about how the RCA engine actually deals with it. So alarms exist in the service topology. So the root cause engine, analytics engine kicks in. It looks, like I said, at the time, the text, and the trend and the topology of the alerts. So then it looks particularly at, well, it normalizes the text first. So it takes out unnecessary words, unnecessary characters, starts comparing that text to other alerts coming in from different places. And then it also looks at the time when these related alerts happen. So also, if the alerts are happening in the same topology, then we'll have to look at it in a way that means that they must be related. So hence, we then go deeper into the topology and look at the thing that happened first. So clearly, the first situation is the root cause of the alerts, but we'll look at that a little bit later in the slides again. So this is all to do with noise reduction. So noise reduction simply, like I said, means that we are reducing the number of raw alerts coming in. We are reducing the number of alarm fatigue. And that obviously makes it much easier for the first level operators to analyze the situation and go through the long list of alerts. And this is achieved in our solution with situations and service alarms, and also partially with dynamic filtering. Okay, the last bit of the slides. So alarm remediation. What can we do once we've detected that there are either raw alarms, there are service alerts, or there are situations? What can we do with it? So what does the first level guide do? So inbuilt in the solution, we also have automated mechanism. So you can assign a ticket to it, to ServiceNow, and the ServiceNow integration is also bidirectional. So if the ticket is updated in ServiceNow, status will propagate back into AIOps. We can also do automated actions such as call a script via Automic, our automation tool. Automic can do various things. It can restart machines, it can increase, change variables, etc., to remediate things that go wrong in the underlying infrastructure. It can also restart applications, application servers, etc. So with Automic, you can do quite a lot of things to fix the problem. And these automated actions are, in this solution, related and actionable directly from the alerts and the situations. We'll have a look at it. We also have other integrations. We call these channels. So ServiceNow and Automic are already mentioned there as part of the channel, yes, but we can also, for instance, push alerts directly into Slack and email. And we also have a generic REST connection with webhooks. We can also determine policies, say that, for instance, even here, you can determine with a policy that, yes, I have a team that wants to know about these alerts in my Slack implementation, but I don't always want to send the alerts. I only want to send the alert in a particular situation. So I can set a policy to it, and according to that policy, then the alerts are sent down the channel wherever they need to go as and when you need to. Okay. An example screen about alarm remediation, and this is now about Automic. Underlying, you'll see an alarm detail view, and you'll see this in a few minutes in the demo as well. So all you need to do really is to click on alarm remediation, and a list of options are presented to you. So the only thing the level 1 operator needs to do is now to select the appropriate action, which is here indicated as a top level percentage. So what the percentage here says is that this remediation action has been executed so many times and it's never failed, so we recommend this for you to use. So even the decision is taken away from the first level operator. All they have to do here is find the situation, click down the situation, so the incident, and click on the first thing that is suggested for them as a remediation step. It's made that simple. Okay. I'll quickly swap to my AIOps or DX1811 screen here. I'm logging into a demo system. So typically when you log into a demo system as well, you'll be presented with this, what we call Launchpad. So I'll click on the operational intelligence, which is the AIOps Alarm Analytics platform. And it takes me to what's called the services. So this is related to the service alarms, obviously. So this is a use case for somebody who's actually looking after business critical business services and looking at problems underlying it. So here's an overview. I've got 53 services which are producing things like my web applications and backends for mobile applications. I'm particularly interested in our WOW service, which is based on our Exchange demo web application because it has problems. 60% health, which is not very good. So what I need to do simply is to click down here. And by the way, my colleague Harish will create a podcast about creating services and much more details about this. So look Harish's demo up at some point. So I get a screen about the health. It's not very good. So what can I do? I just scroll down and I see that yes, we have a lot of service alarms. Okay, 425. So I'll click onto that and I get the service alarms view. You can see immediately that some filtering is already in place by default. So severity critical and the service in concern is the Exchange web. Okay, here are the service alarms. So what can I do? Well, I can first of all click that 3 dots there and get a menu about acknowledging them, assigning them to someone, clear them or hide them. So you can also ignore things if you want to. I can also click on these 3 vertical dots here and do a couple of things like export to Excel, show even closed alarms if I want to, and also keep the view auto updating. Top here, I have the date filtering. We are looking at the last 24 hours here. So this as just a quick example of filtering here. Also, these 3 other buttons here, if I now had ServiceNow integration enabled, I would be able to open a ticket. But to get more details of this particular alarm, the only thing I have to do is click on the particular alarm. Right. And here we have the details screen, the overview. So ID, service affected, alarm message, entities affected in the topology, but in terms of the noise reduction, okay, so in this particular service alarm, so the grouped alarm, we have 3 open alarms, 0 closed. So I actually want to have a look at that. So I click on the view related alarms. And what the solution does for you, as you can see, is list all the alarms, but also indicates the root cause with the blue, with the arrow there on the blue background. So this is most likely the root cause of all these 3 alarms. So all I have to do now as the operator is, well, I can go and have a look at the underlying metric. Here's the 2 anomalies generated and detected. I can also go and compare metrics if I want to compare this to something else. We are looking at concurrent invocation, so I might actually want to look at this and some other metric. But what I really want to do here in this short demo is to click on the Overview tab because I want to do something with it. So Overview again. Here we have all the information about this particular root cause alarm, and I can do 2 things. So I can remediate. And here we have the automatic defined jobs that I can select from to fix the issue. Or if I want to actually have a look at this in a more detailed way, I can also click on the link that would take me back to the APM isolation view. So anyone who's used the APM solution before 10.7, etc., is familiar with the fact that there you can drill down into the actual alerts, the metric, and look at transaction traces, etc., etc. And that's a different use case. That is for somebody who is actually specifically looking at backend errors and backend performance. Here I am just a level 1 guy who now does not need to call somebody who are more experienced to fix the problem. They can simply go and select the recommended action from this list and get the problem fixed. So that's service alarms. Quickly look at the situations. So sorry, I'll just click back on the alarms to get back to the alarm analytics. And I'll look at the situations. Okay, so for the Exchange web application, we don't have many situations. We have only one. But let's have a look at that situation. So, 340 total alarms, 6 still open, 334 closed. So that is quite a situation. Okay, so what do we do with this? So clearly we've had a problem. Most of the issues are already gone, but let's have a look at the related alarms one more time. Okay, so we have 1, 2, 3, 4, 5, 6 clusters generated. So the algorithms in the background, they have grouped these related alarms into one. We can click on the evidences. So the remaining alarms are still there, raw alarms coming in from 6 different entities. I can also have a look at the timeline when the problem started occurring. So here is the earliest occurrence of it. But most of all, I can then click on these different clusters again and remediate. So in this case, we have one open alarm left, and I can do the same thing with situations, go and fix the issue, or go back into APM, because this happens to be coming from the APM solution, this monitoring information. I can fix it or look at it in detail. As a level 1 guy, I'll fix this here using Atomic. So this is the way of reducing noise and the way the solution automatically groups alarms into coherent entities that are easy to fix. There's no need to configure these algorithms. They work by themselves. There's no need to add anything to them. The whole thing is configuration free, pretty much. Just to finish, I'll show you the all alarms list one more time. And here, particularly the what we call alarm insights view that I touched briefly on the other slides. You can also switch this on and off using this button. And these things are clickable. So I can click on the critical to filter. I can click on the variance to filter. I can click on the most offending device to filter the list. I can also add things like I just want to see alarm types from UIM. Well, for that, I need to take the Exchange web out and the critical out as well. Oh, still no alarms from UIM. Okay. But just as an example of how filtering works, there's many ways of filtering, also custom attributes that can be done in the service creation GUI that Harish will show you in a different webcast. But just to recap. So yes, we do filter with quite efficient and dynamic filtering to reduce the noise, but we also have the service alarms and we also have the situations to reduce the noise, to make these thousands of alarms from different dozens, maybe hundreds of different point tools coming in understandable for the level 1 operator who needs to deal with this alarm flood. Okay, so that's the point behind this tool. But with that, I say thank you very much for your attention, and have a good the rest of your day.